Hello everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events and today is one of such events. If you want to find out more about the events we have, there is a link in the description. Go there, click on this link and you'll see all the events we have in our pipeline. We have a few workshops lined up. So tomorrow we have a workshop about identity resolution and next week we have a workshop about pipeline building. And next week we'll also have a podcast interview about MLOps. So if you're interested in these things, go there, check them out, and sign up for those events you like. Then do not forget to subscribe to our YouTube channel. This way you will get notified about all awesome interviews like we have today. And we have an amazing Slack community. Join it if you want to hang out with other data enthusiasts. During today's interview, you can ask any question you want. There is a pinned link in the live chat. Click on that link, ask your question, and we will be covering these questions during the interview. I think that's all for the introduction. Now I will open the document we prepared for you. And we can start if you're ready. You're ready?
I am ready.
Okay, let's start. This week we'll talk about MLOps and DataOps, and we have a special guest today, Santona. Santona started her data journey as a researcher at CERN, then worked in NLP, and then worked as a Python engineer. She did many things, and one of those things we were working at the company behind Airflow, astronomer, right? So she worked in the data space. And now she works at Upsolver, where she leads data engineering and science, doing research, and she will tell us probably more about that. So she's passionate about building as well as empowering others to build end-to-end data and ML pipelines, which will be the topic of today. Welcome.
Thank you so much. Happy to be here.
Questions for today's interview are prepared by Johanna Bayer, as always. Thanks, Johanna, for your help. And let's start. So before we go into our main topic of DataOps and MLOps, let's start with your background. Can you tell us about your career journey so far?
Yeah, absolutely. So I'm a physicist turned ML engineer turned data workflow builder. Yes, kind of. And I feel like I started as a full stack data scientist because, as a physicist, there was data engineering, data modeling, feature engineering, machine learning, and then, result presentation. So I think of myself as a generalist, and now I'm going even more meta in the sense that I want to solve the problems that allow other people to solve their problems. So I'm passionate about building workflow authoring tooling, in a way that it's with the user in mind, where users are other developers like myself, so that we can build the right kind of tooling that helps others do their work as simply, as easily, and as enjoyably as possible. That's me.
Can you maybe tell us it in a few more details, because it's quite a curious career journey. So you worked as a researcher, then you worked as a ML engineer, and then you worked as I don't know if it's the correct way of saying this, as a data engineer. You worked in the data space, before that in the ML engineering space, and before that as a researcher. So what motivated you to actually go into ML engineering? So you were like a full stack ML person as a researcher, right? You needed to do all these things. So why exactly ML engineering? How did it happen to you?
Yeah, that's a great question. So as I was leaving academia and thinking about what's next, at that time, this was in 2019, 2020, it was NLP was pretty exciting. And I mean, obviously, it's still very exciting.
It's more exciting. Yeah, every year it becomes more and more exciting.
Yeah, exactly. So it was so I wanted to go in I was just very, very eager to jump into that field. And so in physics, I was doing work with massive data and fast-moving data and all of those things, but they were mostly numerical and categorical, the data types. So as I did just a few projects here and there on NLP or natural language-based applications, it was really refreshing in the sense that, like, as a human, I could interpret the models and their, the predictions, the inferences that they were making in an intuitive way that, like, this algorithm was also doing. I think that's what kind of what I latched onto. And so I started talking to folks that were doing NLP, and this opportunity arose where we were building a predictive routing engine using natural language queries to figure out how to best resolve them, how to best answer the questions that people were asking. Yeah, that was a lot of fun, building an intent architecture to figure out what people might ask in this entire network it was per product and per language, and then curating that over time, training the classification models over on those intents. It was just a lot of fun. So I would say the transition was more, it was a bit narrower in the sense I was mostly thinking about the ML algorithms, deep neural networks, and sort of the production pipeline in which they were deployed, as opposed to a more end-to-end. And then the other difference was the kind of data and so on and so forth. But it didn't feel like a huge transition because, I mean, at the end of the day, it's still data and ML pipelines serving some end user purpose.
Just text instead of numbers.
Kind of, yeah.
And then you convert text into numbers, and then it's all the same.
Exactly.
Right? Yeah. So, and then this is how you ended up being an ML engineer, right? So, of course, you needed to deploy all these neural nets that you created. You needed to deploy the chatbot, right? So these things needed to be scalable and whatnot.
Yeah, exactly.
But then you decided to go, I think you said, even more meta, right? And focused on more on data workflows. So how did it happen?
Yeah, I think, well, a lot of things sort of fell into place, but I started using Airflow at directly as in the production stack, and workflow authoring. So it all sort of comes down to, like, how your pipelines are orchestrated, right? Or if the orchestration is abstracted away, that's even better. But, like, a lot of this, the engineering component of data and ML pipelines has to do with, okay, what are my dependencies? When do things get executed? What do I do when things go wrong? Fallback protocols, et cetera, et cetera. So, like, thinking about the pipeline as as a main asset, as a main thing to take care of, is the direction in which I was going. And I was excited by the fact that this was Astronomer was a company that was sort of managing that, the Airflow OSS. And it was just I also joined the data team very early as it was being formed. So it was a lot of open, greenfields, open opportunity as far as what we were going to be able to do. And the component of that job that was most fun for me, which maybe I didn't even realize when I was joining, is the user research aspect of it. So I was now thinking beyond the use cases that I had come across, be it particle physics or NLP, to, okay, what is everyone else doing? What is everyone else trying to do with Airflow, or more generally, what are the pipelines? What kinds of use cases are there? So I really enjoyed, like, learning across domains, across industries, what folks were trying to do and what their pain points were, and that, like, got me more and more excited to solve these problems. And that, sort of following that thread is how I ended up at Upsolver. SQL is kind of the lingua franca, right, of data. I really enjoy working in Python, but also, and the other component of this is I love going to places where I know the least, and then sort of building up my education there. So as a physicist, as a CERN physicist, I was working in C++ and some Python. The data structures are these like trees, tuples of tuples, nested data structures that we have our custom storage methods and our custom query methods and so on and so forth. So all of that to say, I'd never used SQL before. So I started using SQL to query data at directly, and then through the years I learned better SQL, and so I wanted to see. So that's part of the motivation actually to coming to Upsolver is we author pipelines, or in our platform, you author pipelines just as SQL, and you just define the outcomes that you want, and then everything that happens, everything that needs to happen to make that possible is handled by us. And of course, we have it's our own dialect, so we have these like keywords like sync versus unsync that like sets a dependency that allows you to say what the dependencies between pipelines, pipeline components are. So yeah, that's sort of like the thread that I followed.
Mm-hmm. I never used Upsolver, so I only receive sometimes marketing information from you in addition to webinars, but I never actually seen the tool in practice. But what you described sounds similar to DBT, right? So you have a bunch of SQL queries, and the tool looks at these queries and figures out in which order these queries need to be executed. Is this a correct assessment?
Yeah, that's a fine analogy to draw. DBT is a good partner of ours, so there's definitely an Upsolver plus DBT story. So specifically, so we do a few different things, and I want to sort of delineate between them. So one is pipeline authoring, workflow authoring. So you can go into our UI and author. You can use our CLE Python SDK, or in DBT, actually, you can author Upsolver pipelines. And then we have the actual engine that executes it. So DBT doesn't have its own execution engine.
DBT delegates it to the data warehouse, to
exactly
Snowflake, BigQuery, whatever.
Exactly, or Upsolver. So with our new DBT connector, so you can write the pipeline in DBT and execute in Upsolver. And we also have, and the second component is we have a lake, a data lake where the data actually lives and flows through, and where you make your transformations on. And then the most recent thing that we added to this already, pretty end-to-end tool is a focus on data ingestion. So we guarantee high quality data ingestion, whether you ingest it into Upsolver or Snowflake, which is also a good partner of ours, or just your S3 bucket. For complex data sources, we found that that's another pain point that folks are struggling with, is if it's CDC, right? You want to do change data capture on your production databases, or you have to pull in data from queues like Kafka or Kinesis, and you're usually used to like batch data processing in Airflow, for example. Then this is sort of a different set of tools that you have to think about, or different mindset. So we're making that very easy. So streaming data, large files, nested structures, and so on and so forth is sort of our specialty. And what we do on the ingestion front is guarantee strong ordering, guarantee exactly once. The things that usually data engineers have to think about while they're doing transformations, we just take care of that at the front end.
Yeah, so a lot of data engineering stuff you mentioned. And I remember a while ago we had a podcast episode about MLOps here. I think it was like 2 years ago. And one thing that the guest back then, CEO, said that you should never confuse a data pipeline with a machine learning pipeline, because a machine learning pipeline is a very special sort of pipeline. So yeah, do not do. This is like a big mistake. And I'm wondering, so what are these ML pipelines and data pipelines? Maybe can you tell us in a few words, and what's the main difference between these two?
Yeah, absolutely. I think it comes down to the application. What is the ultimate value that you're trying to add to your end users? So when I worked at Directly, where our product was this predictive routing engine, where the ML model was the thing that was deployed and is what was receiving data, making a prediction on it, and sending that prediction to end users, that was an ML pipeline. The data engineering aspects of that were very ML focused, which is to say, as you said, we retrieve or we get the question. The question is asked on some UI that then gets sent to comes through to directly through RabbitMQ, receiving that question, vectorizing it, doing all sorts of filters on it. That is the data engineering, which is very, very different from, for example, analytics engineering, which is happening, in Snowflake, let's say, where you're, interacting with the data, you're doing SQL transformations and these things. So it's very focused, in some sense, very focused use case, very specialized kind of use case. It can be computer vision or NLP or multimodal models are also very common. It can be numerical data, but still the feature engineering that's happening, you usually kind of, you do the deep dive as an ML engineer or even as an ML modeler, you do the deep dive, you figure out exactly how your data need to be transformed in order to serve this ML use case in production. As opposed to most data pipelines today, maybe someday this will change, but the vast majority of data pipelines today are serving analytics use cases where you might still have ML as part of the pipeline, but it's not the main, it's not the first-class citizen. It's only because you think that there's something, some pattern, some trend to extract that makes more sense with a regression or with a classification or something like that. So to me, that's difference. Here you're starting with data from different sources. Again, like the source is less relevant, but once your data is in your system, you're really looking at the data, figuring out how different entities in the data relate to each other. So for example, you get your product data from your product, from your application database, you get your CRM data from Salesforce, you get your Zendesk data, et cetera, and then you have to create this model of, okay, what are the different primary entities in my data? What's a mapping between them? How do things relate to each other? And then you try to get to a representation of all of that data that can help serve analytics use cases downstream. So which might be other data engineers on dedicated teams. There are different models, as we know. There's data mesh, et cetera, different ways in which you can power that. But the main focus is building an understanding of the business and then serving up that understanding to end users. And usually the end users, or often the end users, are internal. Like your customer success team wants to know, when a certain client is going to churn. That's the person you're serving. So the other shift there is, who's the persona that I'm building for. So yeah, I agree with the other podcast speaker. I think they're very different. There are certainly elements that are in common. At the end of the day, data is flowing through both pipelines, but it should always be the architecture of the pipeline should always be use case driven, application driven. And then lastly, you didn't ask this, but I'll sort of add, we use the word ops, and I think that it's I think it's a little bit up in the air as far as like how you define it, or maybe there isn't, but I have decided that I use a very simple definition of ops, which is that it's all the steps that I need to take to consistently deliver value to the end user from whatever the thing is. So from data, from ML. So if I have an ML model, great. It already does everything that I needed to do, but getting it from there to actually serving end users consistently, reliably, with little to no downtime. That's my ops portion.
Mm-hmm. So then, using your definition, MLOps would be steps you need to take to deliver value from a machine learning model, and then DataOps would be steps you need to take to deliver value from what exactly? From SQL queries?
I would say from all of your business data, right? Like it's
business data.
Yeah. I don't know. Do you agree that like a lot of data applications today are really, we're trying to build an understanding of the business. So like the representation, the final, there's no final state, but usually the parts of your Snowflake database or whatever else database that you're exposing to other users are meant to be a complete representation of all the data in the business. So
yeah, I do agree. Although being a data scientist, I have a somewhat biased view on this because most of the data pipelines I worked on were more like, how do I transform the data in order to feed it into a machine learning model, right? So then, even though it was mostly a data engineering pipeline, still like last couple of steps were mostly, I don't know, training a scikit-learn model, right? Or publishing the model somewhere. So for me, my understanding of the difference between machine learning pipeline and data pipeline, based on this experience, were that ML pipeline is a more specialized version of a data pipeline, because you have like different steps that are ML specific. Most of the steps are not ML specific, but then you have this feature engineering or like extracting numbers from text, like this vectorization thing that you mentioned, and then training a model which is ML specific, and then, I don't know, publishing this model somewhere. So these last few steps, they're ML specific, the rest are not. So for me, the distinction was that it's just a more specialized version of a machine learning of a data pipeline. But based on your definition or based on what you described, it looks like these are quite separate things. I mean, like one is you focus more on ML, the other you focus more on business understanding. What they have in common is the pipeline part, right? Which is like all this orchestration, but the rest are different. Is it correct understanding?
And they can have the data in common as well. So for example, in also directly, although we primarily had, like, this was our ML product was there, we also did analytics, right? So we did analytics, we ran SQL queries on the data that had come in, so all the historical data, and then what was going on with our ML model, like performance and so on and so forth. I mean, I think that there's definitely overlap and definitely a close marriage. The way that, I mean, definitions are only as good as they're useful, right? So I think the only useful part of the way that I like to think of it is that if you are a data engineer who has been building an ML pipeline, an ML in service of an ML product. So let's say, like, not at a startup where you're doing things end to end, right? So let's say at a larger organization, I'm just going to pull something out of the, like, Reddit or something, or Netflix, where there is a big ML. It's an ML based product, right? The recommendation engine is what's serving the end users, and you have ML engineers that are developing models and deploying models and looking after them in production, and then there might be separately data engineers who are called data engineers, and they're more in charge of, like, upstream, what's happening upstream. So that's another way of splitting it up, is like within the ML application pipeline, you've got upstream data engineers, and downstream you've got ML engineers. So that's totally a valid data engineer persona and workflow. The one thing I will say is that data engineer is used to doing different work than a data engineer at an analytic at a company whose main purpose is something else. So let's say, like, I mean, it's not an ML based model, right? Let's say it's really hard to find these days companies that don't have ML as a product. I'm really struggling, but so your end user product is something. It's not like astronomer. Let's go with that one, right? It's just a managed airflow service. There's no ML component to that. So what were we doing as a data team, right? So our focus there was data engineering for the purpose of building business understanding and serving those up. So there we were thinking much more about how do I represent the data in a way that makes sense to our business partners across the organization, not our ML model, right? So you're thinking human-centrically. You're thinking in terms of, like, what is the mapping here? And you're doing a lot more data modeling. You're doing a lot more of those, like, views and tables that build out. So it's less. So you're as you go down the pipeline, you're getting more denormalized, right? Because you're building these mappings and complex relationships. It's just a very different kind of workflow, in my opinion. And, having experienced a little bit of both, granted, like I definitely want to learn from folks who have done more of either, but I wouldn't hire someone who is building data models in SQL primarily for analytics use cases into a data engineering position for an ML use case straight, like unless they were eager to make that switch and unless they were eager to learn whatever gaps there were. Like it's not a one-to-one mapping between those two data engineering roles.
Even the tools are different, right? So for ML use cases, you might have tools like, I don't know, Airflow, Spark, like all this, like Kinesis, Kafka, RabbitMQ, all these things you mentioned, right? But for the first case, for developing business understanding, the tools are different. Like the tools could be dbt, Upsolver, and these kind of things. And I think when you were saying that, like here, the main goal is to build a pipeline and develop this business understanding and think like, how do I represent the data in a way that's understandable for business? I think there is a term for that right now called analytics engineering, right? Am I correct?
I mean, I think so, yeah. Yeah.
Yeah.
I was pretty excited to see the term come out. I don't see it being used as often. Like I don't see a lot of people with analytics engineer as a title, but I think it makes a lot of sense. Yeah,
we have it. So we have a data engineering course in DataTalks.Club, and one of the modules there is about DBT, and we call it analytics engineering because it seems like it's kind of synonymous. Like people who call themselves analytics engineers, they usually use DBT, and then like if you use DBT, you're kind of an analytics engineer. So it seems like, but I think this is coming from the DBT lab. So they came up with this term to kind of differentiate, to show the difference between usual data engineers and these business-oriented data engineers.
Yep.
Okay, so then we started talking about the tools already. So maybe you can. So what I wanted to ask is like, what sort of tools are usually there? I gave a few examples, but maybe you have more examples. Like what kind of tools different you need for different pipelines, for data pipelines and for ML pipelines?
Yeah, no, I mean, I think you hit the nail on the head. The common stacks today are still some orchestration engine. It could be Airflow. It could, I mean, nowadays there are, Prefect, Dagster, Mage, etc. And you could also, so depending on what kind of transformations you're doing, right? You could also use, let's say, like Spark or Upsolver or something like that for the ML pipelines. It all depends on how you break up your workflow, right? I mean, that's the thing I love about the modern data stack. There's things to hate about it as well, but it is, you can sort of pick and choose your different pieces and build your own. So it's like building your own adventure, kind of. So you can definitely, I think, it's less about the tooling, but on the other hand, I will fully agree with you that a DBT would be hard to use in an ML pipeline, I think, probably. But I don't want to. I'm sure there are teams that are doing it. So again, that's the fun part. But the warehouse aspect of the data landscape, I think, is much more closer to analytics engineering and analytics use cases than ML. I have, nowadays feature stores are becoming a thing, and vector databases and stuff. And obviously, we were building those things for NLP, ML applications. Even 3 years ago, we were building those in house. So it's a data lake, and an S3 bucket with the Hive meta store and so on and so forth. And nowadays there are managed services for that, which I think is cool. Any sort of abstraction, any sort of like, anytime you can take away some work and like, put it abstracted away, I think it's great. But yeah, it's more focused around, you don't really need, as a human, you don't really need to fully grok and understand the data, how it lives and how things relate to each other, as long as you have that layer of metadata that retains that information, and you can have a programmatic querying of it and usage of it.
And you mentioned one thing, you mentioned modern data stack. And you said like it's a good because it's a good thing because it consists of many different components, and then you can kind of replace these components. But what is this modern data stack? I see this term used quite often, but I still like, for me, modern data stack is okay. You have dbt, you have Snowflake. What else? I guess these two, and then like some things for ingestion, and then you call this thing modern data stack, right?
Yeah, that's certainly, I think, a common way to define it. And like, for example, with Upsolver, where would be the third thing, right? Upsolver for ingestion, and then Snowflake and dbt, and that's your modern data stack. That's really all you need for your analytics use cases. But it's a choice, right? It's a choice that you're making. You also have these platforms that, like Databricks, right, that have different have pieces that will allow you to do all of those things. And I mean, it's always going to be, you should make your build and buy decisions and buy and buy decisions by looking at exactly what you need and for your use case. But so it's hard for me to attach a data stack, the idea of a data stack with specific brands and specific companies, because I think that again, what I love about today's data ecosystem, and perhaps it's incorrect for me to use the word today, the modern data stack, more generally in today's data ecosystem, new 3-word acronym. What is cool is that there are these specialized tools that you can pick and choose from. Because if I do a ML application, I don't really want to be working with Snowflake and data and dbt without, because then I'm going to feel a little bit lost because I don't have Python in my hands, right? I mean, granted, Snowflake now has better Python support, but I mean, that's the whole thing is rather than thinking about tools, which then you're at the mercy of the tool to come out with the thing that you're used to or the thing that you need, you can instead, okay, fine, my data lives in Snowflake, great. I can still get it out and work in my, Python environment and do my whatever, and then bring in my ML libraries and do the rest of the work. So to me, that's the modern data experience.
Modern data experience, or you mentioned today's data ecosystem. Right? So what are the building blocks of this data ecosystem? So you mentioned Snowflake, which is a data warehouse, which is the place where we eventually put all the data. The data is already cleaned and ready to be used for analytical purposes. But what are the other components of this ecosystem?
Yeah, I mean, often there is a data lake, whether it's surface to end users or not, as you said, and even within Snowflake or a Databricks, there's usually in tabular representation as well, you usually have like a bronze, a silver, and a gold, like raw ingested and then modeled and then mart, et cetera. So there's that, and you can sort of choose where the data warehouse comes in that data pipeline. But often before we ingest into Snowflake, we will still stage the data somewhere external in a lake, right? Whether it's
to stage the data. What does it mean to stage the data?
I mean, and there are different patterns. And if you use a dedicated ingestion tool, then usually that, I'll start with the definition, right? So data is coming in from some source. It's going to be in a raw format. You pull it in to a place that is meant to be accessed only programmatically and not by individuals, right? So the access controls are programmatic, and then from that data staging area, you pull in the data into a warehouse where it's more human-centric.
I don't want to query that source every time you need the data.
Exactly.
You just pull it once, it's there, and next time you need the data, you take it from that place.
Yeah, I mean that's a way you could design it for sure. You could also just it's part of your data pipeline, right? This I think the staging area is useful because even if you're it's regular, right? It always every day at 1 p.m. my data from Zendesk is pulled in to my GCS bucket or my S3 bucket, and then another DAG, let's say Airflow DAG picks it up from there at 3 p.m. and our DBT model picks it up. And yeah, does DBT work with Lake S3? Probably. I don't know.
I don't know.
But yeah,
yeah.
pulls it into my warehouse, right? It's the staging area is useful because if you do have catastrophic failures, right, then that's a place to catch it. Or if you need to wait for some data, like some services down, and you need to wait for the data and so on and so forth. And like at Upsolver, we're sort of turning that idea on its head, right? You can we're enabling you to do all of those things, like stopping catastrophic failure, or like stopping the pipeline if there's catastrophic failure, or choosing if there are bad quality rows in your incoming data, choosing what to do with them, such as drop or warn, alert, etc. In this ingestion portion, without having to think about the stage, or without having to think about the actual underlying lake underneath it. And we actually we don't need a lake the way that we have written it. The data does move pretty much continuously through without really stopping in Upsolver SQL Lake, but it gets like a lot of the benefits. Anyway, the main thing with a staging area is that it's a holding area. No one's supposed to be learning anything. Like no one's supposed to be querying it. No one's supposed to be making business decision on top of it, but it's like a buffer zone, right? And with more, I think over the years, we've iterated towards more abstracted staging and more hidden staging. So like Fivetran and Upsolver, your data will come in and be staged, but it's within the service, right? You don't have to think about setting up an S3 bucket or a GCS bucket for that staging. So again, abstraction is great.
It's kind of happening, but under the hood. As
exactly.
a data engineer, as the user of Fivetran or Upsolver or other ingestion tool, I do not really think about that. It's happening under the hood, but all I care about is that the data is being moved somewhere, right?
Yeah, exactly.
Yeah,
the data is being moved into my warehouse, or the lakehouse, basically, the lake that I want the data to persist in and want to be able to query.
And if something happens, then I rely on the tool to redo this thing. So I don't physically, or I don't manually go to this buffer zone, to this stage to redo things. I don't even know about its existence. The tool just pulls it from somewhere and redoes the work.
Yep, exactly.
That's cool. That's very convenient.
Yeah.
Okay, and this is how the data ends up in a warehouse, but it's in raw form, right? We haven't processed it yet.
Mm-hmm.
So that's the first initial step of our data pipeline. What happens next with this data?
Sorry. So when you say we haven't processed it yet, we haven't done any complex transformations.
Yeah. What kind of transformations do we actually do at this stage? Do we do any?
In the staging / ingestion stage?
Yeah.
Yeah, I think we don't really think of them as transformations. They're more sort of various cleaning or quality assurance mechanisms. So for example, this is where we would dedupe your data, right? So the kind of thing that you'd have to later on say, oh, let's do a select distinct on my table. You don't have to do that anymore, because every entry is guaranteed to appear only once. And then the exactly once consistency in strong ordering. So those are the kinds of things that we do. The other thing that you can do with Upsolver, I'm not so sure about Fivetran and others, is this is where you can set your PII strategy, your governance strategies, right? So if you have a field that you want to mask, or if you have a field that you want to hash, you can configure those things through the Upsolver UI. And then so like when the data appears, let's say in Snowflake, which is for human consumption, right? The data is already like sanitized in some ways. The things that are hidden, the things that are any duplicates are dropped, and data are strongly ordered.
There is some initial pre-processing which might be enough for some use cases, so it's already ready for some consumption. But maybe for more complex queries, for more complex reports, then a data engineer or analytics engineer need to take this data and do some extra transformation.
Exactly. Yeah.
So the next step, right? The transformation.
Yeah, that is the next step, transformation slash some degree of modeling, right? So the way that I've done it, and I think it's generally a fairly good way of doing it, is your data is going to come in from a number of different sources, even at like small startups. If you have an analytics team, you're going to be able to bring in like 10 different sources of data. So this the next stage of after your data has landed in your warehouse or lakehouse is to figure out what are the well, you'll have primary keys coming in from the data source, but what are basically the mapping keys, the foreign keys? What is the relationship between each of these, let's say, tables that have come in? And what can we build on top of that? Like, what do we actually want to answer as far as for my business? So usually there are very specific questions, and this is why it's important for the data engineers and analytics engineers to talk to the end users, the other teams within the business partners, right, to understand what exactly are you trying to answer. Okay, then I go sort of a back propagation, right, and figure out, okay, to answer this question, I need to pull in data from this table, not that table, and so on and so forth. So that's the kind of modeling where you're thinking in terms of business entities and business questions. So I think that's what's next.
Okay, so here, this is transformation/modeling phase, is when we actually prepare data in order to show it as a report or a dashboard. So here we need to work closely with business people, we need to talk to them, we need to understand what all these keys mean, foreign keys, like everything you mentioned. And we also need to make sure that business people who consume this information, they also understand what's happening in the result we give to them, right?
Yep. Yeah, and there are optimizations that you want to do as a data or analytics engineer, right? You want to make sure that your data isn't like super denormalized and like isn't like the same thing doesn't exist in many different places. The lookup index should be indices across your tables should be efficient. Yeah, I mean there are lots of things to sort of, so for example, in data in motion pipeline, right? If your sources are streaming, then this is the stage where you think about what downstream use cases rely on these streaming upstream use cases, and how do I keep them in sync? So let's say I need to combine two different Kafka queues to answer a question, right? How do I make sure that transformation in the downstream application gets the relevant data from each of those two streams? So, and that's another thing, like sometimes in the batch world, we don't have to think about that, right? Because things are happening in batch. But in a tool like Upsolver, where we're combining batch and streaming and like having the streaming first mindset, then this is where you would really think about, like, how do I do transformations that respect and that stay true to the data dependencies and still answer the questions.
Okay, so we have the ingestion phase, then we have the transformation/modeling phase, and then do we have anything else after that?
Depends. So actually, we said one thing that like I want to double click on. So dashboards and reports and other deliverables, I think, are actually a little bit further downstream, and we shouldn't really be thinking about them at the transformation stage / modeling stage. The requirements are important. I want to know what dashboards folks are wanting to see, or more specifically, what questions they want answered. I don't think that this is something that I said earlier in a LinkedIn post, and it resonated with folks, is you shouldn't come in with dashboard requests to your data team. You should come in with, this is what I want to know. I want to know, this entity that I care about, how is this going to change, or what's a trend, and so on and so forth. And then we work with you. The data team works with you to figure out exactly, how that breaks down, what the metrics are, and how we want to present them. But that whole process is still a little bit further downstream. I think, from the modeling, because you want to get at the modeling stage, you want to get to a place where you feel that the main entities of your business for analytics purposes are covered, are being regularly updated. And then on top of that, so there's a second layer of transformations where you're just going from, okay, I'm taking these entities and I'm just writing the transformation that answers my question. And in some places, this is called MART, right? Or you could go a bit more directly from, those entities into your dashboards. But there's like these two layers. There's ingested data, modeled data, and then there's answers.
Just the data, model data, answers. I'm wondering how different it is for a machine learning pipeline. Because in ML pipeline, we also have a modeling phase, but it's a different kind of modeling phase. But I guess some things are similar, right? So we might still have some ingestion phase, right? Maybe it's not our team who is doing that, but then somehow it's happening. And then we have the data that we can use for transforming the data in such a way that we can use it in order to train a machine learning model, right? So I guess it's somewhat similar, right? So we have ingestion, then we have transformation, then we have modeling, which is a different kind of modeling, because in the first case, in case of a data pipeline, the modeling is more like what kind of things we have in the database, in our data. But here, modeling is actually training the model. And then finally, I don't know, all these other things like serving the model instead of creating a dashboard. Yeah. So it's kind of similar, right? But the tools we use are different.
It's kind of similar, but let's say if my application is an ML application, I don't really need to model the data, as you said, by the entities, right? I don't have to build this business understanding for the ML model to then use that to answer questions, because by that time, it's already like cognitively simple, and there are other ways to do it, or simpler ML models. So in that sense, it's more the feature engineering or data engineering component for the ML application is more focused around how do I best featureize the data for the ML model, not for human beings again. So I think, yeah, largely I feel like it's a matter of who it's for. So the data model that I'm building, who is it for? If it's for analytics use cases for humans, then that's a different mindset, as opposed to if it's for powering an ML model and for a machine to pick up, then it's different. So in feature engineering, you're absolutely right. I have to think about a lot of the same things. I still have to deduplicate my data. I still have to make sure that if like a field has two nulls too often, I have to figure out how to fill that in, or drop, or whatever decisions I choose to make. But at the end of the day, my output is this sort of like vector space, right? This large, or maybe it's not that large, maybe it's smaller, but like all of those decisions I'm making as a ML engineer, as an ML application focused person, and I am working with the data to get it to a better form for my machine to be able to pick up.
Mm-hmm. And now I'm talking with you and I'm wondering, I guess 4 years ago, or when you were doing the switch from I think you said 2019, right? So when you were switching to ML, maybe you did not know about all these things, like all these different steps like ingestion, staging area, and all that. But you were an Airflow user already. So I'm wondering, like, how did you convince Astronomer to hire you with your background?
Yeah, so let me, so I joined Astronomer in, I think, 21. You
already worked as a ML engineer for 2 years.
Yeah. And that's where I was using Airflow. So it was, I mean, yeah, I have the data experience, and in physics as well, just writing data pipelines end to end, doing the like data transformations that I needed to do, and so on and so forth. So it wasn't really a big challenge. There are things that I learned, of course, along the way, coming out of academia, right? That were different. And I think the main thing that I found was things needed to be translated a little bit. So in physics, specifically in particle physics, we used cron, right? We had a job scheduler, custom built job scheduler that was just like most orchestrators and schedulers, like underlying it was just cron, and we had to set our own dependencies, and we had to set our priority on like how important is this job to run, because the jobs were really massive. So, and like when does it need to be run by, and then put it in a queue, and then it gets reprioritized. So all the same considerations, all the same technologies, underlying technologies were there, but we just had a different, like we had a custom solution for each of the different parts, because that's what we needed. Like we couldn't query our particle collision database with SQL or with pandas or so. I couldn't pull it into a pandas data frame. So I realize, and this is going out to folks who are maybe making this transition now, or just trying to think how their skills relate, right? It's not useful for me to say, oh, I have this software, it's called root, and this is where the data lives, and I write this, I open the branch, and then in that data branch, I open the next branch, and so on and so forth. That's not useful. That may be what you're doing, but it's not what folks are going to resonate with. If you instead explain that, well, the tool doesn't matter, but I have this deeply nested data structure, event data, which is how my data is going to be created in particle collisions and how it has to be stored. And in order to do analysis and run aggregates on it, then I have to be able to reach all of the endpoints in my going back to trees and leaves, but all the leaf nodes I have to be able to reach, and I have to run filters across different events on those properties, and then that's my features. Those are my features, and then I do ML on that. It doesn't matter like we had a minimizer it was a custom built minimization engine to find like to get the least, what's the word? To minimize the loss function, right? But you don't have to talk about that. You can say, okay, and then I did this minimization. It was a regression, or it was, whatever else. And this is how I got to the answer. So it's a level of like coming out of the weeds, coming out of thinking about exact tools, and, thinking about this is what I did, and this is exactly what you do as well. So you should hire me because I have experience doing this.
So even though the tools maybe are not like your typical scikit-learn tool, it was something else. And then the way you access data was different, but still at the end, you need to access data, you need to run some modeling, some training process on top of this data, and then you had a model, which is pretty much the steps you need to do now with, SQL and scikit-learn, right? Yeah, I understand. And then you work as a ML engineer, and then somehow you ended up at Astronomer. But you said you used Airflow, so for you it wasn't difficult to convince them to hire you, or was it?
Yeah. I think that having used Airflow was a perk, or was a positive for sure. Doing pipelines end to end, and again, like we were just forming the data team, so there were some open questions around what the data team was going to be, like what exactly the charters were going to be. So like some of the work that I did at Astronomer was NLP analyses. So again, ML for the purpose of analytics, so that's different, or ML for the purpose of showing how you can use Airflow for ML. So that's actually like it was a hybrid role at Astronomer. It's a hybrid role at Upsolver as well. The kind of work that I do is really this like I write data pipelines. Sometimes I write data pipelines to show how a data pipeline can be written using best practices for a specific use case or for a specific domain. Sometimes I craft those user personas and user stories to say, okay, and these are based off of real people. Like my friend at, who's head of ML at this like Series C startup, is doing this. I know he's pulling in data from these sources. He's using Prefect for orchestration. He's, those things. So I write a persona based on that. I write a persona based on my friend who is working at this feature flagging A/B testing platform, and he has this frustration around he's identified a data set that is incorrect, and for the last 6 months he's been trying to stop all the downstream applications because they're flawed, and there's this community. So I write those pain points down and those user stories down, and then I think about how do I solve this using the tool that I want to build and improve. And so then the data work comes in. It's after that sort of market user research. It's after thinking about problems. Then I go to, okay, let me actually write this pipeline, and let me use Airflow to do it, or let me use Upsolver to do it. And now you see that like your pain point is solved, and it's simple in these ways. And there it is. And in the meantime, I'm doing data work, right? Because I'm actually pulling in data. One of the analyses I did at Astronomer was building a predictive model on how long a GitHub issue on the Airflow project is going to take to get resolved. So NLP analysis of the issue title and the issue comments, and then a multi-class classifier on top of that to say, hey, these 10 issues came in in the last 5 hours. This one's going to take days to resolve. This one's can be done quickly, so we can prioritize based on that. So yeah,
it looks like there is quite some overlap between ML engineering and data engineering, because like with the skills you got as an ML engineer, you could just say, hey, like I know how to do this and this. I might not be able to do this thing that you need yet, but I will learn. So hire me, and then, okay, like you seem to be good enough, let's hire you. And then you just learn all the rest at work. This is how it works.
Yeah. And this is why I like being a generalist, and I encourage others to be generalists. It's not like all the words that we use, all the definitions and titles, I think are can be restrictive, right? The more important thing is to actually figure out what the work is that needs to be done and what the gaps are between your skill set and that work, and then fill those in.
Do you have a framework for doing this?
A framework of curiosity. No, I don't have an organized way.
Like, what is this term, right? Okay, look it up, right? This is how it happens.
Yeah.
Do you I don't know, follow some resources online? I don't know, like podcasts or some articles, or it just comes up with conversation with colleagues, or how does it work for you? Where do you get this like, how do you feed this curiosity, and how do you know like what you're curious about in order to learn about that?
Yeah, that's a great question. I don't religiously follow any one podcast or publication, but yeah, I try to again build my own adventure from various sources. Which, if you do, the only concern is vetting, right? How do you vet the right sources? How do you make sure that what you're learning is a good practice as opposed to a bad practice? And that's tricky. But yeah, for that, I mostly rely on my network of folks that I respect and admire. And I am very unafraid to just ask, hey, like, what do you think of this? Or I read this, and this seems like a good idea on principle. Is this what you're doing? Or are you doing something else, and why? So yeah, all of those conversations together with online resources is what helped me learn. I can't really speak to and say like, oh, you should go read this or go listen to this. Maybe someday I will, but not today.
Okay. So you just have a pool of resources, you read from these resources or consume these resources, and then for some things you run them by your colleagues, friends, who will tell you, no, this is actually not exactly correct, right? And then you rethink like, okay, can I trust the source?
Mm-hmm.
Yeah, totally, this is how I do this, then you can see that you can continue consuming from this resource.
Yeah. because then you're getting the real experience from a person who's doing it and building it. I do really like, I should say, companies that have engineering specific blogs, like they're talking about the problems that they're solving in a blog outwardly. That again, like you're getting the real experience of someone who struggled with something and then came up with something. Those are really informative to me.
Yeah. Okay, last question for today. Are there any books or other resources that you can recommend? Well, let's say if somebody wants to learn more about these data pipelines that we discussed.
To learn about data pipelines, again, I'm a little bit hesitant to recommend specific books. I think that depending on what you want to do, because reading a book is also a time commitment. So there's that. But I hear that the fundamentals of data engineering by Joe and Matt is really solid for learning data engineering skills. There's white papers that companies that are in the orchestration space will publish. I found those to be somewhat useful. My friend Bass, who I think is still at Astronomer, maybe not anymore, wrote a book on airflow, basically. And that's solid if you want to specifically learn orchestration with airflow. But I think we're just moving a little fast right now for unless you are a fast reader and for fast someone who learns really quickly, to rely too much on books because they become outdated just so quickly. So yeah, just broaden, consume from other sources as well, like podcasts like yours, talking to folks who are doing the actual work, and reading like shorter form content as well.
Okay, thanks. That's all we have time for today. Thanks a lot for joining us today, for sharing your experience, and thanks everyone for joining us today too. And yeah, I guess that's it for today.
Yeah, thank you so much.
Yeah, have a nice rest of your day and have a great week.